Chandra Sonifications. Astronomers often look at objects in space through multiple telescopes. Because different telescopes can detect different types of light, each brings its own pieces of information to understanding whatever is being observed. This is similar in some ways to how different notes of the musical scale can be played together to create harmonies that are impossible with single notes alone. In the past few years, NASA has been producing sonifications of astronomical data of objects in space. This project takes the digital data captured by its telescopes in space, most of which is invisible to our unaided eyes, and translates them into musical notes and sounds so they can be heard rather than seen. Each layer of sound in these sonifications represents particular wavelengths of light detected by NASA's Chandra X-ray Observatory, James Webb Space Telescope, Hubble Space Telescope, and Spitzer Space Telescope in various combinations. R Aquarii is a system with two stars, a white dwarf and a red giant, in orbit around each other. In the sonification of R Aquarii, the volume changes in proportion to the brightness of sources in Hubble's visible light and Chandra's X-ray image, while the distance from the center dictates the musical pitch, meaning the higher notes are farther out. We can hear jets from the white dwarf as the cursor travels near the 2 o'clock and 8 o'clock positions. The ribbon-like arcs captured by Hubble create a rising and falling melody that sounds similar to a set of singing bowls. These are metal bowls that produce different sounds and tones when struck with a mallet. Meanwhile, the Chandra data are rendered to sound more like a synthetic and windy purr. In Stephan's quintet, 4 galaxies move around each other, held together by gravity, while a 5th galaxy sits in the frame but is actually at a much different distance. The pitch in a sonification of Chandra and James Webb with Spitzer data changes in relationship to the brightness in different ways. The background galaxies and foreground stars in the visual images detected by Webb and Spitzer are mapped to different notes on a synthetic glass marimba. Meanwhile, stars with diffraction spikes are played as crash cymbals. The galaxies of Stephan's quintet themselves are heard as smoothly changing frequencies as the scan passes over them. The X-rays from Chandra, which reveal a shockwave that has superheated gas to tens of millions of degrees, are represented by a synthetic string sound. The third sonification in this new batch is Messier 104, or M104 for short, one of the largest galaxies in the nearby Virgo cluster. As we view it from Earth, the galaxy is angled nearly edge-on. This allows us a view of the spiral galaxy's bright core and spiral arms wrapped around it. In sonifying Chandra, Spitzer, and Hubble data of M104, we begin at the top and scan toward the bottom of the image. The brightness controls the volume and the pitch, meaning the brightest sources in the image are the loudest and highest frequencies. The data from the 3 telescopes are mapped to different types of sounds. The X-rays from Chandra sound like a synthesizer. Spitzer's infrared data are strings. And optical light from Hubble has bell-like tones. The core of the galaxy, its dust lanes and spiral arms, and point-like X-ray sources are all audible features in the sonification of these data.